In this video, we're going to evaluate polynomial functions. And first, we're going to start off with examples just to remind us how to evaluate functions. So first, we have an example. Find p of negative 6 if p of x is equal to x to the fourth minus 2x squared plus 3. Well, you may remember from Algebra 1 that what we do is we're going to take whatever is inside the parentheses and we're going to replace all of the variables with that particular number. So the way I think of it is, what if I rewrite the function with just parentheses and not the variables? Because that tells me I'm replacing that with whatever's in the parentheses here, so negative 6. So negative 6 goes into both of those parentheses. And then I have to remember how to use PEMDAS. If there's anything inside of the parentheses, let's simplify using PEMDAS. Nothing inside the parentheses, then we jump down to exponents, multiplication, division, addition, and then subtraction. So we have to do our exponents first here. To get negative 6 to the fourth power, we're multiplying in a negative number times itself an even number of times, so it will be positive. That's where we get 1,296. Then we have to square the negative 6 to get 36 first before I can multiply it by the negative 2, which then gives me 1,296 minus 72 plus 3, which results in 1,227. But then we learned that not only can we plug in numbers, we can plug in algebraic expressions as well to functions. So let's look at the example c of 3a if the function c of x is equal to 2x squared minus 4x plus 3. Well, it's the same idea. What if I rewrite the problem without the letter but use open parentheses so I know I'm substituting in something? What am I substituting in? The 3a. Each of those parentheses gets 3a into them. But again, I have to do exponents first, or PEMDAS. Can't get outside the exponents or get outside the parentheses without doing the exponents. So I have to square everything inside of here first before I can multiply it by the 2. So that's going to result in 2 times 9a squared. In this term, I didn't have any exponents to worry about, so I can multiply the negative 4 and the 3 to give me the negative 12a. And then I have plus 3. And then finally, I can multiply my terms here to get 18a squared minus 12a plus 3. And I just scan the problem. Do I have any like terms? I got one of the x squared, or the a squareds. I got an a. I have a constant. None of them are like, so I am finished with this problem. That's what c of 3a would look like. But what happens if we start to mix some of this stuff together? What if we want to add and subtract more than one function operation together? Like this, for example. Let's find f of 3c minus 4 and then subtract from it 5 times f of c. There's a lot going on right there. But we're going to break this down into chunks and pieces. And I did colors for a reason here. So first, let's find, well, just the red part is, what is f of 3c minus 4? Well, given our function, f of x equal to x squared plus 2x minus 3, I'm going to start with the x's. I'm going to leave open parentheses so I know what to plug into it. What's going into those parentheses? It's the 3c minus 4. And if you remember, an exponent means let's take the base times itself this many times, which will give us 3c minus 4 times 3c minus 4. And then we got to FOIL out these two parentheses that are here. When you FOIL out the 3c minus 4 times itself, you're going to get this result right here. 3c times 3c is 9c squared. Then you take the 3c times the negative 4, which gives us the negative 12c here. Go to the inside terms. Negative 4 times 3c gives us our other negative 12c. And then our last two terms, negative 4 times negative 4 gives us our 16 that is here. Also, went ahead and distributed the 2 with the 3c to give us the 6c, and the 2 with the negative 4 to give us negative 8 here. But what we have is this really strung out problem here, and we scan it. Do I have any like terms? It turns out I have like terms with negative 12c, another negative 12c, and a 6c in there. We can combine those up to give us the negative 18c that's in the problem, and then we also had negative 8 and negative 3 as like terms with the 16. Add those up, and that's where the 5 comes from. So that's just f of 3c minus 4. We haven't even messed with the 5 times the fc yet, but now we're going to go to it. So that's what step 2 is for. Can we figure out what f of c is and then take that result, multiply it by 5? Well, same way. Let's write parentheses where the x's are at in the function. What's going into it? This time it's going to be just the variable c. And this one is a lot shorter for just f of c, because when I square c squared, it stays c squared. 2 times c is 2c, and minus 3. But that is just f of c. We want it to multiply this result by 5. Do we want to multiply just c squared or the entire function? Well, we want to do the entire function, so we got to distribute a 5 through this function, which turns it into 5c squared plus 10c minus 15. We have both pieces that we need into this problem. So I'll remind you, we were doing subtraction. We're going to take blue and we're going to subtract from it the red. We're going to subtract blue from the red problem. There was our original problem. What was f of 3c minus 4? We worked it all out. That was 9c squared minus 18c plus 5. We're going to subtract from it that product that we got from 5, f of c. That product is 5c squared plus 10c minus 15. And keep in mind, I put parentheses around here because I'm not just subtracting 5c squared. I'm subtracting the whole function that we got. Distribute the negative sign, which changes our signs of everything that I have in blue. And then I can combine my like terms. We have 9c squared. We're going to take 5c squareds away from it, which gave us 4c squared. Our negative 18c, subtracting 10 more c's away from it, gives us our negative 28c. And then finally, 5 and 15 together gives us our 20 down there. So there is our final answer. 4c squared minus 28c plus 20. That's a lot of work. Let's see if we can go through one more example. Let's find g of 5a minus 2 plus 3 times g of 2a. So I'm going to start with red once again. What is g of 5a minus 2? Leave my open parentheses. That way I know from where all the x's are at, so I know what I'm substituting in. I'm substituting in a 5a minus 2 for each of those. You see that we have an exponent here. That means we're multiplying 5a minus 2 times itself twice, which is going to force us to FOIL. As I wrote out these two parentheses twice, I also went ahead and distributed the 5 through the second parenthesis, to where that's where I got our negative 25a and the plus 10. As you FOIL out these two parentheses, you get the following statement here. This is really, again, a problem really strung out. We look for like terms. Our like terms gives us negative 10a with a negative 10a minus another 25a to give us a total of negative 45a. And our constants, 4, 10, and 8, give us 22 down here. So we have the first half of the problem done. Now let's do what I have in blue. Can we find g of 2a first? Leave my open parentheses where the x's were at, so I know that I am substituting in 2a for each of those, and follow the order of operations. In the first parenthesis, we square everything inside of it. Gives us 4a squared. Middle term, we can multiply the negative 5 and the 2a together. And then, if you noticed, we had a 3 out front of this. That means we're supposed to multiply everything that we got from g of 2a by 3. So we distribute a 3 again, similar to what we did with the 5 in the previous example. Distribute the 3, gives us 12a squared minus 30a plus 24. And what did we want to do with all this? Well, in between here, it told us let's add everything together. So we're just going to add all the like terms from the red answer to all the like terms in the blue answer. That is what we're looking at to do here. So we have red plus blue. There's our red answer, plus our blue answer, and there are our like terms. 25a squareds plus 12a squareds gives us our 37a squared. Negative 45a minus 30a gives us our negative 75a. And last term, 22 plus the 24 gives us our 46. So there's how we can use functions to evaluate, or how we can evaluate functions and do more complicated problems